Hey, good morning all. Mechanical properties. We are going for certain definitions in this lecture. So first, elasticity. So in general you will see rubber band, compressed spring. If you apply the force, its dimension changes, right? When you remove the force, again the body, after removing the force, again the body regains its original size and shape. Regains its original size and shape. That property of the bodies we call it as elasticity. Next, plasticity. Plasticity means after removing the force also, the body does not regain its original shape and size. That we call it as plasticity, right? Now next, deformation. So deformation means nothing but when you apply the external force on the body, if its dimension changes, that may be length, breadth, area, volume, whatever it may be, then we call it as deformation. Next, stress. So now stress means the force applied on unit area of the body. We call it as stress. Now strain means the deformation taking place in the body. That we call it as strain. Right? Now this stress is of three types. One is tangential stress. Tangential stress. So tangential stress means nothing but force. The component of force along the surface per unit area. The component of force where it is acting along the surface per unit area, we call it as tangential stress. And the second one, we call it as the normal stress. This normal stress is divided into two types. One is the tensile stress, other is the compressive stress or compression compressive stress. Now tensile stress means, now here I took a object. What I am doing means, here I am stretching the object by applying equal and opposite forces on the either side. Due to that, tension is created. What is tension? The stiffness. The particular force which creates the stiffness in the body, that we call tension. Now due to this stretching of the body, a tension is created, that we call it as tensile stress. Due to tension forces applied on unit area, we will get tensile stress. Now compressive means here what we are doing, we are applying the equal and opposite forces in such a way that it pushes the body. Here it is pulling the body, here it is pushing the body. Means here the body is under compression. So if the force is applied in such a way that, or on an unit area that it compresses the body, we call it as compressive stress. If the force applied per unit area is such that it pushes or compresses the body, we call it as compressive stress. Similarly, strain is also divided into three types. Strain is nothing but the deformation taking place in the body under the application of stress. Right? So, or force. First one, longitudinal strain. It is written as the change in length to original length of the body. If the strain applied is in such a way that the length changes, length of body changes, we call longitudinal strain. The second one is shearing strain. So here area of body changes. So the changes in area to the original area. If the strain is such that it produces the changes in area. Next one, volume strain. The strain is such that it brings the changes in volume of the body. That is change in volume to original volume. Change in volume to original volume. Right? Now next, let us see what is Hooke's law of elasticity. So Hooke's law of elasticity says that within elastic limits, stress is directly proportional to strain. Okay. Now let us see the stress strain curve. On x-axis we are taking strain, on y-axis we are taking stress. From O to A we call it as proportionality limit, that is OA. What is happening? Within elastic limits, stress is proportional to strain, means it is obeying Hooke's law. Okay. Now the second one is elastic limit, that is from A to B. So here what is happening? When stress is removed, body regains its original shape, but it does not obey Hooke's law. Here in first case, when you remove the stress, body regains its original shape. It shows elasticity and obeys Hooke's law, stress proportional to strain. But here body regains its original shape but does not obey Hooke's law. Okay, AB. Now next, the third point, permanent set, or we also call it as yield point. Okay, yield point, permanent set or yield point. So here if you go on increasing the load, the wire stretches. If you go on increasing the load on the wire stretches. And if you remove the load, wire never regains its original length. That we call it as permanent set. Now the fourth one is breaking stress or breaking point. Continuously go on increasing the load. So now the wire length increases, it stretches and becomes thinner. And continuously after that, if you remove the load also, this wire becomes thin and at last it breaks. For smaller loads also, in that position if we apply small load also, the wire breaks. That we call it as breaking point. In such a way, on a wire if you apply the load, in first case if you remove the load, it regains its original size and obeys Hooke's law. In second case, it regains its original size if you increase the load. Next, you increase the load in second case. If you increase the load, it regains its original shape but does not obey Hooke's law. In third case, just further increase the load. Now after removing the load, it will not regain its original shape. And further you increase the load, the wire stretches more, becomes thin. And at that position if you apply smaller loads also, the wire breaks. That we call it as breaking point. Right? Now next, Young's modulus. Young's modulus. These formulas will be most important for your math problems in physics. Stress by strain. It is defined as ratio of stress by strain within elastic limits. F by A by delta L by L, or we can also write it as F L by A delta L. Okay. Next, bulk modulus. Next, bulk modulus. Bulk modulus, it is defined as ratio of normal stress to volume strain. That is F by A by delta V by V, that is equal to FV by A delta V. Right? Now next, reciprocal of bulk modulus, we call it as compressibility. Compressibility. Next one, modulus of rigidity. Modulus of rigidity. Modulus of, I forgot to inform, Young's modulus indicated by Y, bulk modulus by K, and modulus of rigidity by eta, that is equal to tangential stress by shearing strain. Right? That is equal to F by A by theta, or F theta by A. Next, Poisson's ratio. Sigma. This is nothing but defined as lateral strain by longitudinal strain. Longitudinal strain. So this is Poisson's ratio. As it is dimensionless quantity, because strain by strain, it will not have any dimensions or units. Next, energy stored per unit volume in stretched wire is half into stress into strain. Half into stress into strain. Now next, her relation between Y, N, K, eta K or N. First, relation between these are most important for doing problems in this chapter. First, the relation between bulk modulus, Young's modulus. So the relation between bulk modulus and Young's modulus is Y equal to 3K 1 minus 2 sigma. Note down this formula. Next, relation between rigidity modulus and Young's modulus is Y equal to 2 eta 1 plus sigma. Now, the relation between three elastic moduli eta yk is Y equal to 9nk by 3k plus n. Right? Now lastly, let us see some few properties of these materials. Okay, the mechanical properties of material. First one, strength. Strength means the capacity to withstand the destruction under action of external loads. So if you apply the external loads also, that particular material will not destruct. Next one, elasticity, regaining of original shape after external force is removed, right? The third property, stiffness. So stiffness is defined as resistance offered to elastic deformation, we can say, no? Elastic deformation. Next one, resilience means the capacity of the material to store the energy. Capacity of material to store the energy. Next property, plasticity means it does not regain its original size and shape after removing the external force. Next, ductility means the property which enables the material to draw out into thin wire. Malleability, so the property which enables the material to make or flatten it into sheets, right? Next, toughness, the property with which it is able to withstand both plastic and elastic deformation, right? Now lastly, hardness, ability of the material to resist scratching, means scratches will not be on it. Next, cutting or penetration. Ceramics are best example. They have the ability to resist the scratching. Okay, that we call hardness. These are the properties, mechanical properties of material. Thank you. If you like my video, like it, share it. Stay with my channel Reshma Physics to receive more updates and classes related to competitive physics and graduation physics. Thank you.